Hello, this is the last or the last of the first round of demonstration videos we're doing on the use of qtVlm for routine chart plotting. And this one will finish up with probably about the most elaborate type of plotting that one does, barring some complicated radar things. But let's just say for routine work, this is probably one of the more complicated ones, in a sense that what we want to do is a running fix where we're going to account for course changes between the two sites and also then put on a current that's moving, somehow an estimated current that's moving clear across the field, the whole area where we're running. And it's a sort of situation, again, we're dealing with no GPS and we're, say, in the fog. We're in the fog, and the only thing we can see is one light. So one light, and then we have to assume that our compass and log or knot meter is correct, and then we can do our best to figure out where we are based on just compass bearing sights to one light shining through the fog. And that's the exercise we want to do. And this one is it's going to be in the workbook. It's actually an errata to the workbook, exercise number 9-14. And it's around race rocks. And if you're not familiar with race rocks, most people in Northwest are, because it's a famous, the Victoria to Maui and the Swiftsure race go through this race passage here typically as a rule. Here we're going to avoid going through the strong currents. Here we're going to go around here. Currents are still strong, but not nearly as strong as here. Okay, but this is just a plotting exercise. Okay, and so here, let's go back to what we have. We have two bearings. So we have a log. We're using log and compass. We're not using speed. The log is a better way to average out the speed for this type of work. So we have a log rating, like an odometer on a car, log rating. And it is, we have one bearing at 264 when the log is this. And then it looks like about 4.8 miles later, we have another bearing to the same light, which is 053. So let's put that in of what we know then, and here is that race rocks light is right here, 15-mile light. And so we start as always with a pathway. Let's see, delete pathway. Okay, there's no pathways in there. If there were pathways already stored and I say delete pathway, it'd be a list of all the ones that are in there, and there's none in there. I mean, none stored right now. So we're going to create a pathway. It doesn't matter what we call it, but let's just call it 914A. We're going to have several of these to make to solve this problem, and we have to just say we want from the first mark, not from the boat. Okay, and then append POIs, and so we can, well, you can do this a couple ways. If I make the first mark right on the light and the second mark out here, then I have to reverse it. But I could just make the first one out here and put the second one right on the light, okay, there, and then say escape. Now we've got the bearings that were typically made, and the first one was 264M. Now it doesn't hurt always when you're using this, double check. Let's just use the ruler tool here real quick. Ruler tool, straight up, magnetic mode, 340 magnetic, so that's set correct. And so we move this down and we can read magnetic bearings. And what do we want? 264. Oh, there it is, 264. Now, is that right? 264. Okay, so we know we were at 264, we know we were on this line. And then later, let's do another one. Pathway, create a pathway. I'll call this one 9-14B. Again, I could put XXX, it doesn't matter. From the first mark, append POIs. We'll do the same thing. Where is this? 053. Let's be out here somewhere. Let's just go here and do the same thing here. Click this one, then escape. Now this guy is 053. My guess was a little bit wrong. 053. 1, 2. 153. 53. Okay, so what do we know? We know at log reading 52, we were somewhere on this line, and at log reading 56.8, we were somewhere on this line. Now, we have to find out where we are on this line based on what we did between this one and this one. And so if we come back, let me show this picture here. Well, let me actually, before doing that, let me come back here and just show what we've got here. You see we've got a log that shows at log 52, we turned to course 207. And then we went to the logwed 553.9. So that means we went 1.9 miles on 207. And then we switched course to 290. And 290 we sailed 2.2 miles to 56.1 on the log. And then we switched to 215. And then we carried on for 0.7 miles on 215 to the time we took the site, log that. So that is a plot that looks like this. Now, we're not doing any current here. It's generally things like this. You will solve the problem without current, and then we just stick on the current. And so here's what we did. So now what we need to do is basically start anywhere on this first line and do exactly what we did according to the logbook. And we'll end up at some point. Then we take that line and move it to that location. And where that line, that advanced line, then intersects with this line, that's our position. Like that. Without current. So we can start out. Let's just start. And we do this from any place here's another just philosophy. Normally we would take any point on this, and see here's the track we're going to plot like that. And normally we would just start any point on this line and plot out what the DR track was. This is 52. That's what we know we were there. And then you just plot this out like that. Or we could just go any place on the chart and plot this out and then find the vector from here to here, 52 to 56.8, this one straight line. And then bring it back here and do the running fix as if there were no course changes, just using that course and distance made good. But so it doesn't matter how you do that. But in this case, we'll just follow out on this plot here, and we'll just pick some random place on there to start it. So okay, so there now. Okay, so what's all that? That's a pathway. Okay, so we start another pathway, create a pathway. And this is, I think, the third one we've done. So this is 9-14C. And then we start from the first mark and append the POIs. And so let's just start anywhere. So let's start here, say, okay, let's start first one here. I'll have to fix that in a minute. And then the second one here, then we're going somewhere up here, and then we're going somewhere down here. Okay, I just rough that out. Now, I'll start out and put this guy right on the line. And it'll be obvious, what I'm doing. I'm doing this with electronic charting. But with paper, you do exactly the same thing, except you're doing it by hand on paper. So this first course is 207M. How close was I on that? Not very close. Okay, there's 20, and how far do we want to go? 1.9. So there's 1.9 miles, and there's 207M right there, something like that. That's that one. Now then, the next leg is 2.2 miles at direction 290. 2.2 miles at direction 290. .280, 290. What is that? 2.2. Okay. That should be 2.2 at 290, exactly. Now this one's just a little short one. That's 0.7 at 215. 0.7. Let's go back. There's 0.6. That's 0.7 at 215. I'm just moving my mouse. Now again, we showed, okay, 215. Okay, well, let me zoom in here a little bit. Might be easier when you're zoomed in. All right, I want 0.7 at 215. Yeah, it's definitely easier. Okay, now there's 0.7. There's 0.7 at 215. Okay. Now, so that's our track right there. That's our DR track. Now, we don't know that we were here. We could have plotted it over here or something. But anyway, so there is that. Now what I need to do is take this line as if I had parallel rulers and move it over here. Move it over here. As if, one way to think about it is I just bolt this to the boat so it can't rotate, right? It can't rotate. And then I just drive over here and find out where we are. Okay, so, or does it rotate? Let me not pursue that analogy. I may get in trouble. But we know what this heading, we know what this heading is. It was 264. So one way that I can sort of simulate drawing this line with parallel rulers over here is just take this guy here and append the POI and go up here to this direction, and make it 264. 264, right? Like that. Then, that's actually did it. See, normally, sometimes I might, depending on where this is, then I might have to just backtrack this line, come here. But anyway, whoops, we don't need that. Right click, delete. Oh, no, excuse me. Okay, hang on just a minute. I don't want to delete that line after all that work. Delete. Yes. Okay, so there's our fix right there. You see, this is just a little stub of this guy, but basically this line here, this line right here is the advanced LOP of this line. And there's our fix. So I can go right down here, new mark, and I can call this mark 9-14 fix no current. And in fact, the problem, okay, no current. And the problem asks for that. The problem asks for the solution with current and without current. Okay, so that's the answer. Oh, and I can right click it and edit it. And then as soon as you edit it, I can copy it, right? If I copy that, okay, cancel. Now, if I can go here, let's see here what I did. Command B, 48. Oh, here's what I did before class started. Oh, pretty good. All right, so I got the same answer. That's good. So I've just cut and paste. That's a way you can extract from the program the digital value of any mark. In fact, any place on the chart, if I want to know where the G is, I can right-click, say New Mark, and then say Copy, and then close it. I don't even have to make a mark, right? Cancel. And then I've captured that lawn. Okay, but no, okay, so we got the first part of the problem is solved. Now we need to assume that there was current flowing, and what was that current? 1.7 knots in direction 098. And with this type of work, we do have to assume that current was constant over the full time and region we covered. Here, that's semi-reasonable for this area. Semi-reasonable. Okay. But that magnitude, 1.7, that's easy to have 1.7 knots at that area. So whether or not how steady it is for over a period, it's not that long a time here. We got, 40 minutes. Well, we're going to have to know that. We're going to have to know that. It looks like it's 43 minutes, actually. Yeah. Okay, so now we want to add the current. And so one way to do that is to just take this last point where we did, not the fix, it's this one here. This was the DR. This one I should probably label. Okay, let's go in and label that. This is the DR position. Well, I can just say DR at a log reading at log 56.8. Log 56.8. Okay. No current. Okay, so that's a DR log 56.8, no current. Now all I have to do, what we do now, the next philosophy is, I just take this point and adjust it for the current. And so we have to figure the current, and let's see what we have here. It looks like we have, okay, let's just do this. And we also have to be careful between true and magnetic, because all this is plotted magnetic, right? But then currents are always told to us in true. So we have to think about that carefully. But anyway, from 1220 to 1303, that is equal to 43 minutes. And so we're going 43 minutes. So that's 43 minutes, 43 divided by 60 times 1.7 knots means that we've moved 1.2 miles. So it's 1.2 miles in that direction, which is 078 M. Well, I'm doing everything here in M. So I would just go here. I better start a new pathway. Let me write down what we're doing here so I don't forget it. We're going 1.2 miles in direction 078 M. 078 M. Okay, I don't want to forget that. All right, and now I need a new pathway. Create a pathway. This would be 9-14D maybe. And from a new mark, okay. All right, now I would just go to, let me just do it this way. Oh, I forgot to append P. Pathway, edit a pathway, D. I forgot to hit, I don't know why I didn't hit append. Okay, let me just do this. Let me put one here, and what's our direction? 078 M, something here. I'm going to just do that and just get the lines on the paper. Now I can zoom in and put this guy right on top of that. I could have probably just fixed. That's not right. That's not where I want it. Sorry. I want it over at the DR. Sorry. Well, so you have to, when you get all these lines on the chart and you're doing all these corrections, we do have to pay attention. But this comes out of the DR. In other words, I'm correcting my course made good. Originally, I just assumed my course made good was back there up to here, right? But now I'm going to fix this guy. So he's going to come right on here. And now we do the current 1.2. Oh, it's a big, that's on this scale. Okay, 1.2 at 078. See, all these lines are going to get all over the top of each other. 1.2. Oh, wait, 078. Okay, you see, okay, I want that just changing to 1.2. Okay, and then I want 078, which is going to be up just a little bit. No, down just a little bit, rather. There. What do I got? 1.2 at 78. Okay, now let me go back out. Now we do the same trick again. What we want to do basically now is take this line That's the original LOP. Advance it to this point, right? Not to where we did before, which was this point. So we do the same trick. We'll zoom in here, and we'll take this thing, and we'll we'll append POI and come out here somewhere. Okay, and then where is our other line? This is it. Oh, okay, so we have to go further out this way. And we want 264. Okay, 264. Okay, okay, so that's here. This is the current, 1.2. And then we have to move this line parallel to this line, and this crosses here. I'm surprised that fix now is really not that, oops, this we don't need, delete. Yes. Okay, so now the fix with now the fix with current is here. A new mark, 9-14. With current. Okay. And that fixes here. Let me just take a ruler tool. That's not very far different. I'm surprised, but anyway, there's different angles here on these lines, and sometimes if things are right in the same direction as a line. Anyway, that's the answer I get for that one, which that's the numerical answer right there. And so that is the process. I'm going to just do this, edit, copy, and then I'm going to come over. Okay. This is now with current. When you do this type of copy in the waypoints here, you get this extra information that you don't need. So, but anyway, that's with current, that's with no current. Okay, so I'll stop there. That is then a running fix done with multiple course changes between the two fixes, between the two sites, and then adding to it a current. In this case, a fairly large current, and that was the answer we got. I'm going to think through, not on live time here, but think through why these fixes are as close as they are. Okay, that's it.